Alrighty, CNT125, we're continuing our Chapter 8. Before we tackle the next topic, we're going to catch this little idea here about network services across subnets. We just talked about implementing subnets, so now they remind us that when I have subnets, let's look at their example here. When I have a router and I have two separate networks, sometimes it's cost prohibitive, or I might not have the equipment to have a DHCP server on each network. So what can happen is a router like this can be configured to pass the DHCP request along to the network that has a DHCP server and the reply back. So they tell you here, you can use a relay agent on a router like that. You would be like an IP helper type command that you would be using that'll actually take the DHCP request from here, pass it over to this guy, and then if there's a server, I'm sorry, I'm going backwards. The request from the DHCP, the client right here, the DHCP request, it would pass it along to the network that has the server on, and then pass the reply back to it. The reason they're mentioning that is a DHCP request by default is a broadcast. So normally would hit this router and stop and wouldn't go any further. But you can configure that port traffic, they show you there 67, port traffic can get forwarded through the router over the server and the reply comes back. That can be handy when you're implementing subnets. You don't have to have a DHCP server on each subnet. We can actually pass the request from one subnet to another one. Let's now take a look at variable length subnet mask. Traditional subnetting, we actually have a waste of IP addresses when we really get down to it. Think about when I cut up a pizza or pie up. Let's say I have a pie there and I cut it in 8 pieces and I scoop all the pieces out. When you look in the pan, there's inevitably cheese or pie filling left behind, or crust or crumbs. Correct. When I do subnetting, there's always addresses that can't get used. There's network numbers and broadcast addresses. So there's always some kind of crumbs left over when I subnet. Sometimes, excuse me, even some of the examples we did, sometimes we only needed, 2 or 3 subnets, but we borrowed enough bits to accommodate that need, and we have 1 or 2 left over that I am not using. Now, they can be for future use, but that also could be waste if I don't have any need for that future use. So variable length subnet mask is a way to minimize that waste. What I end up doing is subnetting a subnet. Sometimes they'll call this supernetting, if you will. So what you do is you start by allocating subnets based on the largest pool of hosts that you need, and then you keep breaking the pieces down further until I get pieces small enough to accommodate the other groups that I need. So I start with a large group and I work my way down. So the scenario they have in the book, excuse me, I'm going to walk you through. Suppose we have a 192.168.10.0 network, /24 default. I have this octet here, these 8 bits here to work with, so I have 256 addresses to work with. And we have a scenario where the company needs a couple subnets, and they're focusing on the number of hosts that are in those subnets. They say sales has 120, accounting has 58, HR has 25, IT 6, executive 5, WAN link 2, and another WAN link 2. So the first thing you do is you rank all these in the largest need first and the smallest need last. And what you end up doing is allocating a large subnet for this, and then you take the other subnet and you break it into pieces to accommodate this, and so forth as you work your way down to get to the smallest one. So in this example, I'm just going to try to show you here what's going on. First thing is I'll borrow 1 bit to create 2 subnets. So I have subnet 1 and subnet 2. The first subnet will accommodate this need. Well, if I break my 0 to 256.5, I have 128 numbers. So that first subnet, 128 numbers, will accommodate this 120 host need. So when I borrow 2 bits or borrow 1 bit, I get 2 subnets. The first one gets allocated to the sales there. The other half now is going to get used to accommodate these, but we're going to take this and continue breaking it into smaller pieces. So now that I've done that, I borrowed 1 bit right there for the /25. We will now, this section here, again, we're going to borrow 1 more bit. We'll do 26 now, and that's going to take that 128 to 256 or 255 and break that in half. So basically 64 numbers each, if you will. So we now have a subnet here to accommodate accounting, and the other subnet will be left over for these right here. So we're then going to do this one more time. We borrow one more bit to take this block down here, that 64 numbers, if you will, break it in half again, and we're going to allocate here a chunk here for this subnet right here. It'll be like 32 addresses, and that'll accommodate the 25 that are there. And then the other will be here for these guys. Next time we're going to borrow 2 bits, so we can create 4 subnets. And my subnet 4 and 5 will accommodate the IT here. Because I have, with my subnet now, I have, as you look here, basically 8 numbers. 6, 7, 8 numbers here, so we can accommodate the 8 that are here with the 6 that are needed here with 8, the 5 that are needed here with 8. So this subnet 4 and 5 will accommodate with these 8 numbers each, and subnet 6 and 7 will be left for the last. And what we can do now, those last 2, we borrow one more bit, and we create 2 subnets, and I now have a subnet of, as we see here, 4 numbers to accommodate this WAN link and 4 numbers to accommodate this WAN link. And I still have a little bit of space left. I still have a little bit of space left that I could use for future use, but I have very little waste compared to breaking this up into evenly sized subnets that would not accommodate this range of numbers. That is what variable length subnet mask is and what it's doing. And it's the idea of I allocate a big subnet here, and then this half over here I break in half and allocate here. This that's here I break maybe in half and allocate here, and then I start breaking these into smaller pieces till I get everything in. 25, 26, 27, borrow 2 bits, so 29, 29, one more bit, 30. And that's what I end up with then, to accommodate those different populations. That's your variable length subnet mask. We're kind of introducing the idea here. Networking people, as you move on to 220, you will be doing a bunch more of this in your labs. So we're just kind of getting the idea out there for you. We want to get the basics of traditional subnetting under our belt so that we can migrate onto this in 220. When we come back in the next podcast, we'll move on to IP6.